Number 1. The Naden Harbour Carcass. On July 8, 1937, the catcher vessel SS Bloom delivered a 13.7-meter sperm whale to the cutting deck at the Naden Harbour whaling station on Langara Island in the Haida-Gwaii archipelago off northern British Columbia. Workers opened the stomach as part of the standard rendering process. Inside, they found a partially digested vertebrate roughly 3.05 meters long. It had a small reptilian head, a long camel-like neck, a single pair of small flippers near the head, and a tapering serpentine body. 2 men present that day became the central witnesses, station manager James Wakelin and Captain Trevor Wenban Smith. Wenban Smith took 3 black and white photographs of the carcass laid across the cutting deck. 2 of those photographs were sent to Dr. Neil Carter, the founding director of the Pacific Biological Station at Nanaimo. Carter forwarded copies to Francis Kermode, director of the Provincial Museum in Victoria. Kermode's preliminary report described a creature distinctly reptilian in nature and unlike any cetacean previously catalogued from these waters. The carcass itself was rendered to oil and meal within 48 hours. That single 48-hour window is what makes this case so difficult to revisit. No tissue, no teeth, no bone survived. The case was closed by the standard operating procedure of a working whaling station. The photographs and Carter's notes were stored at the Provincial Museum until the early 1940s. During the wartime reorganization of the museum's holdings, the file disappeared. Only 3 low-resolution copy prints survived, reproduced in a 1947 Victoria Daily Times feature, and then again in 1995 in Edward Bousfield and Paul LeBlanc's monograph titled An Account of Cadborosaurus wilsii. Bousfield, then a senior zoologist at the Canadian Museum of Nature, argued the carcass was the first physical specimen of an unidentified North Pacific marine reptile. He named the species Cadborosaurus wilsii. The mainstream rebuttal advanced by paleontologist Darren Nush identified the specimen as a fetal baleen whale, possibly minke, distorted by partial digestion. A more cautious third reading, published by University of British Columbia ichthyologist Dr. Don McAllister in 2011, concluded that the surviving photographs were too low resolution for definitive identification, but that the head morphology is inconsistent with any known cetacean fetus. The Royal British Columbia Museum's standard reply to correspondence on the case has, for 30 years, been the same 3 words: records lost. Number 2. The Hook Island Sea, Monster Photographs. On December 12, 1964, the French photographer Robert Le Sirec, his wife Ramonde, their 2 children, and a deckhand named Henk de Jong were anchored in shallow turquoise water off Hook Island in the Whitsundays, North Queensland. Their boat was the Saint-Yves d'Armor. Ramonde Le Sirec was first to see it. She described an enormous black snake lying motionless on the white sand seabed at roughly 9 meters depth. Le Sirec estimated the creature at 24 to 27 meters long, roughly 80 feet, tadpole-shaped, tapering tail. A small head set with what he described as pale slit-like eyes. He took at least 7 black and white photographs from a small dinghy directly above the creature, and 1 short cinefilm sequence on a 16mm camera. After photographing it for roughly 15 minutes, Le Sirec and de Jong entered the water with a snorkel and a spear. The creature opened its mouth toward them. Both men fled to the boat. The family departed within hours. The creature was never seen again. The photographs were sold to Australian Post magazine in February 1965 and syndicated worldwide. Queensland Museum zoologist Dr. Vladimir Korodkov and ichthyologist Hugh Edwards questioned the images on the grounds that the creature appeared unnaturally still. In 1967, Edwards produced a partial physical reconstruction from black plastic sheeting weighted to the seabed. He argued the photographs depicted a hoax. The hoax explanation has never been physically confirmed. No plastic sheeting was ever recovered from Stonehaven Bay. The photographs show no visible weights, seams, or tethering structure. A 2003 cinematographic reanalysis by image specialist Dr. Tony Healy at the University of Queensland identified no image manipulation artifacts in surviving original prints. The motive evidence against Le Sirec is real. 8 months before the sighting, he reportedly told a Sydney journalist he intended to find something at sea that would make money. But Le Sirec died in 1996 without recanting, and his account remained consistent for 30 years. Marine biologist Dr. Ben Roush noted in 2008 that the proposed dimensions exceed every known shark, eel, or cetacean recorded from the Coral Sea by an order of magnitude. A 2018 sonar survey of Stonehaven Bay by James Cook University recorded no anomalous benthic features. The IUCN Cryptid Working Group now classifies the case as indeterminate, insufficient physical evidence for either authentication or refutation. Number 3. The Persian Gulf Light Wheels. The first formal entry appears in the Royal Navy logbook of HMS Vulture on May 15, 1849. The commander, R.E. Harris, wrote, "Vast spokes of pale, luminous light radiating outward from a central point beneath the hull, rotating in a clockwise direction at approximately 4 revolutions per minute." That was the first one. It was not the last. Between 1849 and 1910, the Marine Observer Journal collected and published 67 separate first-person captain's reports of identical phenomena. The geographic range covers the Persian Gulf, the Arabian Sea, the Strait of Malacca, the Gulf of Thailand, and the South China Sea. The wheels were typically described as 30 to 200 meters in diameter, with between 6 and 40 visible spokes. Rotation speeds reported range from roughly 1 revolution every 5 minutes to over 12 revolutions per minute. The color was almost universally described as milky pale blue, or greenish-white. That color is consistent with the bioluminescence of the dinoflagellate Noctiluca scintillans. The chemistry checks out, the geometry does not. Dr. Peter J. Herring of the National Oceanography Center in Southampton proposed in 1985 that the wheels are produced by surface pressure waves from breaking swell, or from seismic microtremors, stimulating bioluminescent plankton in geometric patterns. The Herring model accounts for the bioluminescence, but not for the consistent geometric symmetry of the spokes. A second model came from Soviet marine geophysicist Dr. Konstantin Korotkov in 1990. He proposed that the wheels are produced by subseabed seismic resonance, creating standing wave patterns in shallow water columns of less than 70 meters. The Korotkov model successfully predicts the geographic distribution. The reports cluster over shallow shelf seas above seismically active basement rock. But it does not predict why the wheels rotate. Modern reports continue. In 2008, the Polish freighter MV Lichtenfels logged a 90-meter clockwise wheel in the Strait of Hormuz for 14 minutes. In 2019, the Indian container vessel MV Janitha logged a similar event in the Gulf of Oman. NOAA's day-night band low-light imager on the Suomi NPP weather satellite has confirmed roughly 6 Milky Sea events in the same region since 2019, but has not yet captured a rotating wheel event in progress. Stephen Miller of Colorado State University, writing in Deep Sea Research Part 2 in 2017, called the wheels an unsolved interaction between bioluminescent organisms and an unidentified geometric forcing mechanism. The Royal Navy still maintains standing reporting orders for the phenomenon under Hydrographic Notice 14. Number 4. The block Ness monster vertebrae. On October 10, 1996, the new London registered trawler Mary M hauled in a partial trawl roughly 38 nautical miles southeast of Block Island, Rhode Island, from waters approximately 80 meters deep. The skipper was Captain Carl Schuler. Among the catch was a 4.27-meter articulated section of vertebral column, fully fused at every joint, and 24 individual vertebrae. Each vertebrae measured roughly 15 centimeters in diameter and 18 centimeters in length. The neural arches fanned outward at an angle of approximately 60 degrees, rather than rising vertically as in known sharks or rays. Schuler photographed the column on the deck of the Mary M and transferred it for examination to the Mystic Aquarium and Institute for Exploration in Mystic, Connecticut. Dr. Greg Scomail, a senior fisheries biologist with the Massachusetts Division of Marine Fisheries, examined the column on October 13th. He announced a tentative identification as basking shark. The identification was based on the cartilaginous rather than osseous structure of the centra, but Scomail noted at the time that the angle of the neural arches was atypical for the species. That note never went away. Basking shark vertebral counts in mature specimens range from 105 to 115. The Mary M specimen represented at most 24 vertebrae. The fisherman reported the hull was clearly only a partial column, with both ends broken. Centrum diameter of 15 centimeters in basking sharks is observed only in individuals of approximately 9 meters total length. A 9-meter basking shark with only 24 vertebrae preserved would be missing roughly 4/5 of its column. No further skeletal material from the same individual has ever been recovered. Repeated commercial trawls of the same coordinates between 1997 and 2015 produced nothing. Independent re-examination of the radiographs in 2005 by ichthyologist Dr. Henry Mollett at the Monterey Bay Aquarium Research Institute identified the century as consistent with basking shark, but flagged the neural arch geometry as atypical and unexplained. Mollett's note in Copea in 2006 concluded that identification as Ceteraneus maximus is provisional pending recovery of additional skeletal material, and that the neural arch deviation from species norm has no current taxonomic explanation. A 2011 DNA extraction attempt by Dr. Robert Bondi at the U.S. Geological Survey failed to recover amplifiable mitochondrial DNA. The column is still on public display at Mystic Aquarium under intake accession 1996.10.10.001. Number 5. The whistle and train sounds. On May 1, 1997, NOAA's Pacific Marine Environmental Laboratory hydrophone array recorded an ultra-low frequency signal designated whistle by lead acoustician Dr. Christopher Fox. The array itself was the repurposed Cold War SOSUS network, originally tuned to detect Soviet submarines, retasked for oceanographic research in 1991. The whistle signal had a peak frequency of approximately 27 Hz, a duration of 7 minutes, and a rising and falling pitch contour reminiscent of a long mechanical whistle. The signal was recorded on only one hydrophone in the array. That single fact closed the case before anyone could open it, with only one hydrophone, no triangulation. With no triangulation, no source location. The whistle is formally from nowhere. 2 months earlier, on March 5, 1997, the same array had recorded an entirely different signal. This one was designated train, a rising tone holding at a steady frequency for several minutes before slowly fading. Train was located by triangulation to the southern edge of the East Pacific Rise. The most likely explanation is friction-driven vibration of moving ice against the Antarctic continental shelf, transmitted through the SOFAR channel, but even train has a residual. The pulsation envelope is inconsistent with pure ice friction. Dr. Robert Dziak, who succeeded Fox as lead PMEL acoustician, has cautioned that the pulsation has no clean physical model. Whistle has no clean physical model either, in any direction. Dr. Fox classified it in the original 1997 catalog entry as a biological candidate, meaning the harmonic structure was more consistent with a vertebrate vocalization than with a geophysical source. The 27 Hz peak is within the range of blue whale calls, but the harmonic envelope does not match any catalogued blue whale call type. Dr. Kate Stafford's 2017 analysis at the University of Washington concluded the harmonic structure was non-anthropogenic and not matched to any cataloged cetacean species. The signal was never recorded by any other hydrophone in the global SOFAR channel network, despite the 27 Hz frequency being well within the SOFAR transmission band that carries such signals across entire ocean basins. Dr. Dziak said in a 2012 ENAA podcast that whistle remains genuinely unknown, and that he expects it will stay that way unless the modern global array recaptures something similar. The CTBTO International Monitoring System, expanded since 2004, has not. Bloop has since been reclassified as an icequake. Whistle and train have never been reclassified. They sit on a public NOAA webpage, unsolved. Number 6. The Stronsay Beast. On September 25, 1808, a violent late summer storm struck the North Atlantic. On the following morning, 3 farmers on the island of Stronsay in the Orkneys discovered an enormous carcass washed ashore at Rothisholm Head. Their names were George Sherrier, William Folster, and Thomas Fotheringham. They measured the carcass with a length of rope. Total length, 16.76 meters. 55 feet. Maximum girth, 3.05 meters. 3 pairs of paddle-like limbs. A long mane of bristly fibers extending along the back. Their accounts were taken under sworn affidavit before the Sheriff of Orkney in November of 1808. The carcass itself was rapidly broken up by the tides. Sketches were made. Several pieces were preserved, including a section of the cranium, a portion of the spinal column, and a piece of the mane. The preserved specimens were sent to Patrick Neal, secretary of the Wernerian Natural History Society of Edinburgh. In 1809, Neal formally described the carcass as a new species and named it Hulsidrus pontoppidani in honor of the 18th century Norwegian bishop and naturalist Eric Pontoppidan. The London anatomist Sir Everard Home, then president of the Royal College of Surgeons, disputed the new species identification in a paper to the Royal Society later in 1809. Home argued the carcass was a decomposed basking shark. That identification became the accepted scientific explanation by the mid-19th century and remains the mainstream view today. The decomposition mechanism is real and well documented. Basking sharks lose the gill apparatus and lower jaw first, leaving the cranium and spinal column resembling a long-necked, small-headed carcass. The bristly mane has been interpreted as the exposed ceratotrichia, the fin rays, that become visible as connective tissue rots away. But the model does not match the measurements. 55 feet exceeds the largest reliably recorded basking shark by approximately 25%. Basking sharks have only the standard cartilaginous fin pairs, pectoral, pelvic, and caudal lobes. 3 pairs of paddle-like limbs is not basking shark anatomy. The skull fragment preserved by the Wernerian Society was lost in the early 19th century during a transfer of the Society's collections, before Home could test his hypothesis against it. Orkney historian Dr. Tom Muir re-examined the original affidavits in 2008. He concluded the witnesses were reliable independent observers and that their measurements were consistent with each other and with the contemporary sketches. Bernard Heuvelmans's 1968 classification still stands. Likely misidentified basking shark, but anomalies remain. Number 7. The Tasmanian Globster. On August 7, 1960, 2 cattlemen named Ben and Reg Fenton were riding along 4 Mile Beach on the remote western coast of Tasmania between Sandy Cape and the Interview River. They came across a large pale mass washed up on the strand. They measured it, 5.5 meters long, 2.4 meters wide, 1.2 meters high, an estimated 5 to 10 tons. The brothers described the surface as pale white, covered with stiff bristles, having protrusions resembling tusks at one end, and a series of slits along one flank that looked like gills. The carcass had no head, no obvious appendages, no mouth, no eyes, no skeletal structure. News of the find did not reach the Tasmanian government until March of 1962. 18 months had passed. By then, the carcass had partially weathered, but the bulk of it was still in place. A CSIRO expedition led by zoologist Dr. Bruce Mollison and pathologist Dr. R.J. Goss visited the site in March of 1962 and took tissue samples. Their report described the tissue as rubbery, fibrous, resistant to decay, and unlike any vertebrate tissue we have examined. The analysis identified neither bone, nor cartilage, nor any recognizable internal organs. The mainstream explanation was advanced in 1962 and reiterated 4 decades later. The Tasmanian Globster was a decomposed mass of whale blubber, most likely from a sperm whale. Collagen-rich blubber resists decomposition far longer than musculature. The model accounts for the rubbery texture and the white color. Australian marine biologist Dr. Jeanette Watson re-examined the surviving CSIRO photographs in 1995 and proposed the bristles were exposed collagen fibers and the tusks were tendon stumps from a decomposed jawline. That accounts for 2 of the anomalies. The gill slits do not have a clear analog in sperm whale anatomy. They remain unexplained. The phenomenon of globsters has been recorded approximately 21 times worldwide since the original St. Augustine specimen in 1896. Dr. Sidney Pierce of the University of South Florida published a 2004 molecular biology study on the Newfoundland, Bermuda, Chilean, and Nantucket globsters. All 4 samples were consistent with sperm whale collagen. The Tasmanian globster was never molecularly tested. The tissue samples did not survive intact past 1965. The carcass itself was washed back to sea in late 1962. The Australian Museum's Marine Biology section still classifies the case as open. Taxonomic identity not established with certainty. Number 8. The Chilean Blob. On June 23, 2003, a 13-ton gelatinous mass washed ashore at Los Muermos in the Los Lagos region of southern Chile, approximately 1,000 kilometers south of Santiago. The mass measured roughly 12 meters long, 3 meters wide. The color was pale pink-gray. There were several thick stump-like protrusions resembling severed tentacles. Local fisheries officials notified Dr. Elsa Cabrera, director of the Centro de Conservación Cetacea in Santiago, who traveled to the site on June 28th. Cabrera initially identified the mass as the remains of a giant octopus, Octopus giganteus. That species name itself has its own history. It was first proposed in 1896 on the basis of the St. Augustine carcass. A second expedition team, led by Dr. Sergio Letelier of the Museo Nacional de Historia Natural in Santiago, arrived on July 1st and collected tissue samples for laboratory analysis. The samples were sent to Dr. Sidney Pierce at the University of South Florida. Pierce's analysis, published in 2004 in the journal Biological Bulletin, identified the tissue as collagen, consistent with the blubber of Physeter macrocephalus, the sperm whale. That identification is the current mainstream consensus. Cabrera disputed it publicly. She noted that the collagen architecture in the Los Muermos specimen showed a regular grid-like fiber pattern not previously documented in sperm whale blubber. The grid-like architecture has never been independently re-examined. The surviving tissue samples are still held at the Museo Nacional de Historia Natural under accession MNHN-2003-06-23-001. The strongest anomaly in the case is simpler. There were no skeletal remains. A 13-ton sperm whale carcass would typically include identifiable skull, vertebrae, and rib material. None of these appears in the Reuters photographs taken by Eduardo Sorensen on June 28th. No fluke, no flipper bones, no jawbone fragments. Cabrera proposed in 2004 that the mass represented decomposed muscle and connective tissue from a much larger, currently uncategorized, marine animal. The Chilean government issued no further statements after Pierce's publication. The case is closed at the ministerial level. Sperm whales of sufficient size to produce a 13-ton blubber mass have been recorded stranding along the southern Chilean coast roughly once per decade, which supports the sperm whale identification. The Los Muermos site sits on a complex of cold water upwellings along the Humboldt Current, where deep water species occasionally surface. Cabrera has continued to maintain in interviews that the identification was published with insufficient corroboration. The specimen is the largest globster ever documented worldwide by total estimated mass. Number 9. The Bondi Beach Carcass. On August 6, 2009, a small carcass roughly 70 centimeters long was discovered at the northern end of Bondi Beach in Sydney by a local surfer named Tim Brunero. The carcass had 4 short legs, prominent canine fangs, pale, leathery, hairless skin, and an elongated rat-like body and tail. Photographs were uploaded to social media that morning and circulated globally within 24 hours under the informal label, the Bondi Monster. New South Wales Department of Primary Industries Fisheries Officer Dr. Julian Pepperell was dispatched to examine the remains the following morning. By the time Pepperell arrived, the carcass had been removed by Waverley Council Waste Management. Council protocol clears all biological material from the beach within 24 hours. The whereabouts of the carcass were never publicly confirmed. Freedom of Information requests since 2009 have produced no information on its disposal route. Waverley Council's standard biological disposal protocol routes such material to a commercial incinerator within 48 hours of collection. If the protocol was followed, the physical specimen no longer exists. Pepperell examined Brunero's photographs and concluded the carcass was consistent with a partially decomposed brushtail possum that had lost its fur to bloating and saltwater exposure. The brushtail possum identification was disputed by independent zoologist Dr. Carol West, who noted that the dental morphology in the photographs showed clearly carnivorous canine teeth, incompatible with the herbivorous dentition of a possum. The third possibility, advanced by West and several other amateur naturalists, was a partially decomposed bandicoot or quoll, both Australian marsupial carnivores, but neither species typically reaches the body length recorded in the photographs. The case attracted media attention from CNN, the BBC, and the Australian Broadcasting Corporation. The BBC Nature Unit's chief consultant Dr. Mike Linley concluded in a 2009 interview that without the carcass itself, taxonomic identification is impossible from photographs alone. The Australian Museum's Mammal Department was not consulted on the case during the August 2009 news cycle. A 2010 review of the photographs by University of New South Wales zoologist Dr. Dan Looney included the carcass in a class of modern unidentified small mammal strandings alongside the 2008 Montauk monster and the 2009 Panama creature. The Montauk monster was eventually identified by photographic comparison as a decomposed raccoon. The Panama creature was eventually identified as a sloth. The Bondi Beach carcass has no comparable conclusive identification. The Australian Cryptozoology Research Group archived it in 2010 as indeterminate. Most parsimonious explanation is possum, but inconsistencies remain. It is the highest profile unidentified mammalian carcass from an Australian coast since the 1960 Tasmanian Globster. Number 10. The Gloucester Sea Serpent. Between August 6th and August 23rd, 1817, residents of Gloucester, Massachusetts reported repeated sightings of a large serpentine creature in the waters of Gloucester Harbour and adjacent Cape Ann. The creature was described as approximately 27 meters long, 90 feet, dark in color, moving in vertical undulations, producing a visible series of humps along its back. A horse-like head held a meter above the water's surface. Sightings were made by at least 30 separate witnesses. They included the harbor master Joseph Allen, the schooner captain Solomon Allen, the fishermen Matthew Gaffney and James Mansfield, and the U.S. Justice of the Peace Lawson Nash. Nash collected sworn affidavits from 11 witnesses between August 14th and August 22nd under his judicial authority. The Linnean Society of New England, then the Principal Natural History Society of the United States, convened a formal investigating committee on August 19, 1817. The committee comprised the physicians Dr. John Davis Williams and Dr. Jacob Bigelow and Judge John Davis. They traveled to Gloucester, took testimony, and reviewed the Nash affidavits. In November, a fisherman near Gloucester killed a small black snake-like animal approximately 3 feet long with a series of dorsal humps. The committee accepted this as a juvenile of the harbor serpent and named the species Scoliophis atlanticus, the Atlantic humpbacked snake. The 52-page Linnean Society pamphlet appeared the same year under the title A Report on the Sea Serpent. In early 1818, the French-American naturalist Charles-Alexandre Lesueur examined the juvenile specimen at the Philadelphia Academy of Natural Sciences. He identified it as a deformed common black snake with spinal abnormalities. The Linnean Society quietly retracted the Scoliophis atlanticus designation in 1819. But the Lesueur identification of the juvenile did not address the 30 adult witness accounts. The Linnean Society of New England itself dissolved in 1823, 4 years after the retraction, partly under the embarrassment of the case. Sightings consistent with the Gloucester serpent continued along the New England coast throughout the 19th century. At Nahant in 1819, at Lynn in 1833, at Cape Cod in 1856, at Mount Desert Island in 1875. The Boston Society of Natural History maintained a working file on the New England sea serpent until 1880 before archiving it without conclusion. Marine biologist Dr. Charles Paxton at the University of St. Andrews published a 2009 statistical analysis of the Gloucester affidavits in the journal Archives of Natural History. He concluded that the witness testimony was internally consistent and inconsistent with mass hysteria. His preferred explanation was a misidentified large eel or oarfish. The original Nash affidavits are still held at the Cape Ann Museum in Gloucester. Step back from the 10 cases for a moment and look at the shape they make together. The recurring feature is not what was found. It is what happened next. The physical evidence is repeatedly recovered and then quickly lost. The Naden Harbour photographs disappeared during the wartime reorganization. The Hook Island 16mm negatives passed into private French archives and were lost track of. The Marine Observer Journal, which logged 67 Persian Gulf light wheel reports across 79 years, ceased publication in 2002. The block Ness vertebrae are still on public display, but with no recoverable DNA. The NOAA whistle signal exists as a single hydrophone recording with no possible source triangulation. The Stronsay Beast skull fragment vanished during a Vertebrae Society collection's transfer before it could be tested. The Tasmanian Globster tissue samples did not survive past 1965. The Bondi beach carcass was incinerated within 48 hours. The 1817 Nash affidavit survived, but the juvenile Scoliophus specimen examined by Lesueur is now untraceable in Philadelphia Academy storage. The most parsimonious reading is that ocean discoveries are simply more vulnerable than terrestrial finds. Seawater exposure, decomposition rates, and remote recovery sites mean the standard archive and conserve workflow does not fit the material. That is a real constraint. It is not the whole picture. A second reading is institutional. High-profile re-identifications create a quiet incentive to lose or to deprioritize the original material. The Linnean Society of New England dissolved within 4 years of the Scoliophus retraction. The Wernerian Society dissolved in 1858. Both case files moved with them. A third reading is more speculative. Each individual loss appears coincidental in isolation, but the aggregate produces an archival shape that prevents any cross-case material study from ever being assembled. The phrase "scientists refuse to explain" describes part of this. The other part is slower and quieter. It is the slow drift away from the file. The single physical phenomenon that explains away the most of these cases is also the one that explains away the least. Depending on whom you ask, basking shark decomposition, sperm whale collagen blubber decomposition. The shared property is identical. Both produce pale, fibrous, semi-rigid masses that retain their gross morphology long after losing skin pigmentation, fins, gills, and skeletal landmarks. Basking sharks lose the gill apparatus and lower jaw first, leaving the cartilaginous spinal column with a small skull attached that resembles a long-necked serpent. Sperm whale blubber resists bacterial decomposition because of its collagen architecture, leaving a featureless pale mass long after the bones have washed away. The model accounts for the Stronsay Beast's small head, spinal column, and bristly mane. It does not account for the 55-foot length that is 25% beyond the largest reliably recorded specimen, and it has no analog for the 3 pairs of paddle-like limbs. The model accounts for the St. Augustine, Newfoundland, Bermuda, and Nantucket globsters, which Dr. Sidney Pierce's 2004 molecular work tied to sperm whale collagen. But the Tasmanian sample was never molecularly tested, and the Chilean grid-like fiber architecture has never been independently re-examined. The mainstream view is that every globster and every sea serpent carcass is a decomposed basking shark or sperm whale, and the remaining anomalies are witness error and limited photographic detail. The intermediate view is that the model accounts for the majority, but not for the outliers. The Stronsay limb count, the Tasmanian gill slits, the Chilean fiber grid. The fringe view is that the decomposition model has been retrospectively applied to suppress engagement with morphologically genuine outliers. The fringe view is not necessary. The intermediate view is enough. The decomposition problem is resolvable. The institutional appetite to actually resolve it is in 2026 optional. The specific technological capabilities that exist now and could, in principle, close several of these cases are not exotic. Nanopore portable molecular sequencing can extract field DNA from soft tissue samples even after seawater exposure. The Chilean blob tissue at MNHN-2003 is still in storage and has never been re-examined with these methods. NOAA's day-night band low-light satellite imager on Suomi NPP and its successor on NOAA-20 is capable of imaging milky seas and potentially rotating light wheel events. No such event has been satellite captured yet because the Royal Navy reporting orders under Hydrographic Notice 14 are not networked with NOAA's tasking schedule. The CTBTO International Monitoring System Global Hydrophone Network post-2004 was designed to detect nuclear tests. It is technically capable of recording a whistle-class biological signal. Its sensitivity tuning is calibrated for impulsive events rather than for the 7-minute harmonic envelope the original SOSUS array could resolve. Dr. Robert Ziek has argued that retuning a subset of the IMS array could, in principle, recapture a whistle-class signal if one occurred. No funded project exists. Portable CT scanning has been used at the Mystic Aquarium since 2018 on cetacean strandings. The block Ness vertebral column on permanent display would in principle accept a non-destructive scan to resolve the neural arch geometry. The scan has been proposed, never funded. The mainstream view is that the cases are resolved enough not to justify the funding. The intermediate view is that academic incentives favor novel results over re-examination of historical material. The third view is quieter. Some of these decisions are individual rather than institutional. A single curator, a single tasking officer, the discretion to keep a sample boxed for another decade. None of this is occult. The samples exist, the instruments exist, the proposals exist, the funding does not. A precise tour of the surviving physical and documentary material is shorter than it should be. The HMS Vulture 1849 logbook sits at the National Maritime Museum in Greenwich under catalog ADM 53/1429. The original 1809 Furnarian Society paper sits at the National Library of Scotland under catalog 6.21. The Mary M. vertebral column has been on display at Mystic Aquarium since 1998, intake accession 1996.10.10.001. The 2003 Los Muermos tissue samples are at the Museo Nacional de Historia Natural in Santiago under accession MNHN-2003. The 1962 Tasmanian Globster CSIRO file is at the National Archives of Australia under Series A 1209/110. The 1817 Nash affidavits are at the Cape Ann Museum in Gloucester under Catalogue 1958.0042. The NOAA whistle and train recordings sit on the Pacific Marine Environmental Laboratory Acoustic Monitoring Project website, publicly downloadable, free. That is roughly 40 individual artifacts across 8 institutions and 4 continents, accessible by appointment to any researcher with credentials. None of them has been the subject of a coordinated cross-case re-examination project. The mainstream view is that no funding body considers a project on decomposed marine animals through history competitive against contemporary research priorities. The intermediate view is that no single researcher's career incentive aligns with a multi-decade synthesis of historical curiosities. The speculative view is that a coordinated project would be quietly discouraged at the senior peer review level on grounds of reputational risk. The practical reality cuts through all 3 views. The material is physically retrievable, it is not classified, it is not destroyed. It is not even particularly hard to find. The Hook Island images, the Naden Harbour photographs, and the whistle recording are accessible online to anyone with a search engine. The institutional refusal, if that is the right word for it, is not a refusal to release the material. It is a refusal to engage with it. Take the 10 cases not by chronology, but by category. 3 carcasses brought up from inside other animals, 3 carcasses washed ashore, 2 photographs, 1 dredge, and 1 acoustic signal. Across 2 centuries of physical evidence collected from the ocean, the recurring failure is not at the moment of recovery. It is at the moment of follow-through. The Naden Harbour station rendered everything to oil within 48 hours. The Bondi carcass was incinerated within 48 hours. The Linnean Society of New England wrote a 52-page report in 3 months and then dissolved itself within 6 years. The Vernarian Society named a species in 3 months and lost the bone fragment before the rebuttal arrived. The CSIRO took 18 months to reach the Tasmanian beach. If the technology now exists to resolve several of these cases, and the artifacts physically exist in identifiable storage at named institutions, the absence of resolution is no longer a function of evidence or instrument. It is a function of choice. The phrase that gave this video its title is sometimes literal. More often, it describes the slow institutional reflex to set the case down quietly and walk away. The carcass goes back to sea. The samples sit in storage. The logbook stays catalogued and unread. The signal stays on a public webpage that no funding body has commissioned anyone to listen to. Each individual decision was reasonable in its moment. The aggregate is an archive of cases the ocean delivered, and the surface world stopped processing. The deep sea, in these cases, is not hiding anything. It already pulled the discoveries up. The refusal is on land.